Hello, and this is going to be problem session 2 of chapter 3. Actually, we're going to work a couple more problems from your homework assignment in chapter 3 again to help you a little more. So I'm going to start with this problem that I printed out from when I accessed Connect and looked at the homework. It says Ellis Auto Troll plans to install an eco-friendly energy recovery system that will cost an estimated $86,900 if it is installed 7 years from now. So this is out in the future, this $86,000. The company uses an interest rate of 10% per year compounded continuously, and we haven't worked one with continuous compounding, but as I mentioned, it's the easiest kind. All you have to do is plug into equation 3.3 and get the effective rate and press on. So the question is, how much could it spend now? How much can the company spend now essentially to avoid spending this if this is the interest rate? Well, so this is asking you, what's P? P is equal to question mark. We're given that the future value of this is 86,900, and that's at n equals 7 years from now. Okay, so we have a rate here. The rate is 10% per year compounded continuously. And then from equation 3.3 we have that the effective rate for some period of time, and what we want is annual since we're dealing with years, annual rate is equal to e to the r annual minus 1. Now this is the effective interest rate formula 3.3 when it's continuously compounded. Of course, if it's discrete compounding, we use equation 3.2, which we've been doing in previous problems. So this will be equal to e to the 0.1, that's 10% or 0.1, minus 1. And if you work that out, you'll get that number is 0.10517 or 10.517%, moving to decimal place too. So everything we need we have now, and we're looking for present value. We have a future value. That's a single payment kind of problem. We have our number of years and we have our rate, so it's just a matter of plug and chug. Now, present worth is equal to the future value. Find P given F at rate I for n periods. The future value is 86,900. We find P given F. The rate is 10.517%, and that's percent per year, and this is n equals 7 years. Now you can go look that up in your app, or you can actually, whenever you deal with a P and an F or an F and a P, the equation is very simple. It's 1 plus I to the n or 1 plus I to the minus n. In this case, we're bringing money back in time, so it's 1 plus I to the minus n, so it would be 86,900 times 1 plus 0.10517, that's 1 plus I to the minus 7, or you can, like I said, do it on the app. If you do, you'll get $43,153, and that's the solution to this particular problem. The next thing I'm going to do is solve one last problem for you. This one is kind of a long-winded problem. The problem is long, but the solution is not. So the author is trying to kind of give you information about how the the Treasury bond system works. And this is a particular kind of a Treasury bond. It's called a TIP or TIPS, which is an inflation-adjusted Treasury bill. So Treasury securities are used and backed by the U.S. government, and therefore are considered to be the lowest risk securities on the market. As an investor looking for protection against inflation, you are considering the purchase of inflation-adjusted bonds, known as U.S. Treasury inflation-protected securities. By the way, when people talk about securities, they're talking about stocks and bonds. So a stock in a company is a security and a bond. Bonds are issued by the U.S. government. They're also issued by corporations. Bonds are just loans. Stocks are a form of ownership. So if you own stock in a company, you're an owner. But if you own bonds in the company, you're a lender to that company. They're a borrower from you. And so if you own TIPS, you're a lender to the U.S. government, and they're a borrower from you. Anyway, that's kind of background information. With these securities, the face value, which is paid at maturity, is regularly adjusted to account for inflation. Now, that's not true of almost all other bonds. Only TIPS have their face value adjusted. So when we study other kinds of bonds, that doesn't happen. The face value is always constant for anything but TIPS. However, the semi-annual interest payment, called the bond dividend, remains the same. So the bond dividend is based on the original face value, not the changing face value. You purchased a 10-year, $10,000 TIPS bond with dividend of 4% per year payable semi-annually. So that means it's going to pay 2% of that $10,000 every 6 months. That's $200 every 6 months. Assume there is no inflation adjustments for the first 5 years. So you got a 10-year bond. The first 5 years, there's no inflation adjustment. But in years 6 through 10, the bond face value increases by $1,100 each of those 5 years. Okay. Use an expected investment return of 13.5% per year. Wow. That's only a 4% bond. Wow. Compounded semi-annually, so this is not an effective rate. This is a nominal annual with twice annual compounding. This is a multi-part question. We don't need to know that. What will be the equivalent future value of the total money received with dividend reinvestment included? Okay, so what he's assuming is that every 6 months you're getting $200. So let me draw that up in a cash flow diagram. This is the first, for example, this is the first year, 1 year, but the first 6 months you get $200. At the end of the second 6 months, you get another $200, and that's going to go on every 6 months for the entire 10 years. Now, at the end of the 10th year, you'll get your last 6 month cash flow of $200, and you'll also receive the face value. I'll just call it little f for now. How much is that little f? Well, it went up $1,100 each year for 5 years from $10,000. So this is going to be equal to $10,000 plus 5 times 1,100, which is going to be 5,500, so that'll be 15,500. So that's what your future value is at that point in time. And whenever you deal with a bond, you get your last dividend, and then at the same time, you get the face value of the bond, which in this case has gone up most of the time. For most corporate bonds, they're $1,000, and that's just $1,000. But this is a $10,000 TIPS. It's a government bond. So the question, though, is what is the future value of this cash flow, the whole thing? F equals what? The rate is 13.5% per year, compounded semi-annually, twice a year. Well, we've got semi-annual payments. That's a 6-month period here. So what I need is the semi-annual effective rate. I need I semi-annual. Now, I semi-annual is equal to 1 plus R semi-annual over M to the M power minus 1. But what is R semi-annual? Well, R semi-annual is just half of this, because that is the nominal annual rate, 13.5. That's the nominal annual rate. The nominal semi-annual rate is half of that. So this is going to be 1 plus 0.675, that's half of 13.5%, divided by 1. How many times is it compounded in a semi-annual period? Exactly once, the 1 minus 1. Once you get to realizing how this thing works, you might be able to do it in your head. Certainly, this is, this is 0.065, okay? So this is going to be 6.75%, or as a decimal, 0.0675, because you're dividing by 1, raising to the 1 power, not changing anything, adding 1 and subtracting 1. So now we're going to get the future value of this cash flow at this rate. This is the semi-annual rate. These are semi-annual payments. There's 20 of them. So I have two things out here in the future. I have this face value. So the future value, F, will be that face value because it's at the future time, 15,500, plus this uniform series, its future value. Well, that's an amount A, $200, F/A at rate I for N periods. Now, these are payments or dollars per semi-annual period. That's got to be the semi-annual rate. That's got to be the number of semi-annual payments. So this is going to be 6.75%. This is going to be 20 because it's 10 years. 15.5 plus 200 times F given A at 6.75% per 6 months and 20 6-month periods. If you crank through that, you're going to get $23,479. And that's the solution to this bond problem. And that will do it.